NASA's solar system exploration mission, Europa Clipper, is in the making. It is scheduled to launch in October 2024 in a Falcon Heavy rocket from the Kennedy Space Center. In fact, NASA has a live YouTube channel where you can watch it being assembled step by step. I inserted the link in the description. Although we all would like to see the potentially amazing data it sends back to Earth as fast as possible, we will have to wait a good amount of time before we can see the results. In the meantime, let's dig into the details of the mission. When it launches in 2024, it will follow a Mars-Earth gravity assist trajectory. The spacecraft will travel for 5.5 years and arrive at Jupiter in April 2030. Clipper's spacecraft will perform dozens of close flybys of Jupiter's moon Europa, gathering detailed measurements to investigate whether the moon could have conditions suitable for life. Europa Clipper is not a life detection mission. Its main science goal is to determine whether there are places below Europa's surface that could support life. The Hubble Space Telescope has revealed the presence of persistent water vapor from Europa. This could indicate that there's an ocean under the icy surface. The Clipper spacecraft, in orbit around Jupiter, will make nearly 50 flybys of Europa at closest approach altitudes as low as 25 kilometers above the surface, soaring over a different location during each flyby to scan nearly the entire moon. Okay guys, let's dig into the technical part. With its massive solar arrays and radar antennas, Europa Clipper will be the largest spacecraft NASA has ever developed for a planetary mission. In fact, there will be 9 custom-made high-tech instruments on the spacecraft. Let's take a closer look, starting with the cameras. Europa Imaging System, ICE. A wide-angle camera and a narrow-angle camera, each with an 8-megapixel sensor, will produce high-resolution color and stereoscopic images of Europa. They will study geologic activity, measure surface elevations, and provide context for other instruments. It will capture Europa's valleys, ridges, dark bands, and other features in profound detail. ICE will map 90% of Europa at 100 meters per pixel, 6 times more of Europa's surface at 5 times better resolution than ever before. This is currently at step 2, meaning hardware is delivered. Europa Thermal Emission Imaging System, (ETHEMIS). The thermal imager uses infrared light to distinguish warmer regions on Europa where warm liquid water may near the surface or might have erupted onto the surface. It will also measure surface texture to understand the small-scale properties of the surface. This might also help to find sites for a possible future lander. This is currently in step 3, meaning it is delivered and attached to the spacecraft. Now let's take a closer look at the spectrometry instruments. Europa Ultraviolet Spectrograph, Europa UVS. By collecting ultraviolet light with a telescope and creating images, the mission's ultraviolet spectrograph will help determine the composition of Europa's atmospheric gases and surface materials. It will also search near Europa for signs of plume activity. Different elements emit and absorb specific wavelengths of light. The instrument records how bright the light is at each of those wavelengths. The resulting data contains the telltale signatures of atoms and molecules. It tells scientists exactly what material the light passed through or reflected against. This instrument is at step 3, delivered and attached to the spacecraft. Mapping Imaging Spectrometer for Europa, (MICE). Living things interpret physical phenomena in a variety of ways. Sounds at various frequencies can signal threats or sources of food. Likewise, image and color and their interpretation indicates much about its source. The mission's infrared spectrometer will map the distribution of ices, salts, organics, and the warmest hotspots on Europa. The maps will help scientists understand the moon's geologic history and determine if Europa's suspected ocean is suitable for life. And for those who want to go even more in detail, infrared light enters mice through a slit. Mirrors direct the light to a calcium fluoride lens, which directs the light to a grating. The grating cuts light into discrete wavelengths, which then strike a detector. This is currently at step 1, hardware development. Next is the plasma and magnetic field instruments. Europa Clipper Magnetometer ECM. The magnetometer investigation aims to confirm that Europa's ocean exists, measure its depth and salinity, and measure the moon's ice shell thickness. It will also study Europa's ionized atmosphere and how it interacts with Jupiter's ionized atmosphere. The magnetometer boom will be 8.5 meters long with 3 flux gate sensors. To fit aboard the rocket, the boom will be stowed in a canister. It will deploy to its full length in the days after launch. It is still at step 1, hardware development. Plasma Instrument for Magnetic Sounding, PIMS. Europa's ionosphere and plasma trapped in Jupiter's magnetic field distort magnetic fields near Europa. PIMS Faraday cups will distinguish those distortions from Europa's induced magnetic field, which carries information about Europa's ocean. PIMS has 4 sensors called Faraday cups to study plasma's density, temperature, and velocity. Each cup is about 8 centimeters deep and 20 centimeters wide. A grid near the top of each cup produces an electric field to blow unwanted particles. In the bottom of each cup is a flat, circular detector plate with 3 120-degree segments, like a pie with 3 equal slices. Plasma creates an electrical current when it strikes the plate, revealing the plasma speed and density. PIMS is now at step 2, hardware delivered. Radar and gravity. Radar for Europa assessment and sounding, ocean to near surface, reason. Europa Clipper will carry 9 instruments with overlapping abilities and responsibilities, but only one can look directly into Europa's icy shell. The radar will probe Europa's icy shell for the moon's suspected ocean and study the ice's structure and thickness. It will also study the moon's surface elevations, composition, and roughness, and search the moon's atmosphere for plumes. Reason transmits radio waves that bounce off features within the underlying ice. Some radio waves return to the spacecraft, but at a fraction of their original energy. By measuring the time difference between transmission and return, and knowing the speed radio waves traveled through various materials, Reason learns how far the features are from the spacecraft. This is at step 1, hardware development. The next one is not really directly an instrument, but a cooperation between scientists on Earth and the Clipper spacecraft. It is an important part of the mission. Gravity/radio science. Europa and its gravity field flex as the moon's non-circular orbit carries it closer, then farther from Jupiter. Measuring Europa's gravity at various points in the moon's orbit will show how Europa flexes and help reveal its internal structure. In gravity experiments, radio antennas on Earth send a radio signal to Europa Clipper. The spacecraft then transmits to Earth at a frequency coherent to what it received. The gravity science team precisely analyzes the Doppler shift and other aspects of the radio signal received on Earth. Currently at step 1, hardware development. Instruments for chemical analysis. Mass spectrometer for planetary exploration / Europa, MASSPEX. The mass spectrometer will analyze gases in Europa's faint atmosphere and possible plumes. It will study the chemistry of the moon's suspected subsurface ocean, how ocean and surface exchange material, and how radiation alters compounds on the moon's surface. MASSPEX generates high-energy, fast-moving electrons to strip electrons from incoming gas molecules. That makes the gas molecules into positively charged ions. The instrument accelerates the ions to a uniform amount of energy. The ionized gases are pulled into the drift tube, which gives MassPex its baguette-like length. The lighter the ion, the faster it can move through the drift tube. Currently at Step 1, Hardware Development. Surface Dust Analyzer, SUDA. Tiny meteorites eject bits of Europa's surface into space, and a subsurface ocean or reservoirs might vent material into space as plumes. The dust analyzer will identify that material's chemistry and area of origin and offer clues to Europa's ocean salinity. When dust enters SUDA, it passes through a series of metal mesh grids that measure the dust's speed and trajectory, which identify the dust's area of origin on Europa's surface. The dust then strikes a metal target plate that splatters dust grains into individual molecules and ionizes some of them. Once ionized, the molecules must obey SUDA's electrical field, which funnels them to a detector. An ion's mass to charge ratio determines how long it takes to reach the detector. The timing reveals the molecule's mass and composition. Amazingly enough, it can also identify whether organic molecules are abiotic, meaning not derived from living organisms, or biomolecules, meaning it is derived from living organisms. SUDA is at Step 2, Hardware Delivered. As you understand, this is going to be an incredible spacecraft, packed with components to do hardcore research on Jupiter's moon from a distance. Europa Clipper will only be the third spacecraft to orbit the largest planet in our solar system and the second spacecraft to run on solar power at Jupiter's distance from the Sun. It will also be the first NASA mission to exclusively study a moon other than Earth's moon. At launch, Europa Clipper will weigh approximately 6,000 kg, about 65% of which will be fuel. Its solar panels will span about 30 meters, wider than the length of a basketball court. The mission's name is a reference to the lightweight clipper ships of the 19th century that routinely plied trade routes around the world. The name was chosen because the spacecraft will sail past Europa as frequently as every 2 weeks. If this mission is successful, and it is indeed an ocean under the ice, we will likely see the Europa lander mission being realized. But for now, let's enjoy the journey of the Europa Clipper mission. So, what do you think is under the ice of Jupiter's moon? Is there an ocean at all? Is it salty or not? Will we discover microorganisms or maybe something bigger? Make a comment underneath, we would love to hear your thoughts. If you like this video and want to get more updates about the Clipper mission and other future missions, please subscribe.